Hello. So since I'm on this website already, graphtoy.com, it's a website I discovered that just really easily you can just click on things and it just shows you the graph plotting of the whatever function you give. So I've just been looking at graphs lately that are useful for GLSL language, and I'm noticing that a lot of people like to use the logarithmic and exponential graphs. So I'll show them. Okay. Um, what I've noticed is that the RGB color scale uses pretty small numbers that are positive, which means that if I wanted a graph that has some interesting value, maybe I should pick values that have some type of significant change or behavior that is unique inside this area where the values are positive and still small. Um, and a lot of people use log and exponentials, so that means that it seems like this area is of interest. And log and exponential are also just like exactly opposites of each other, so that's another interesting thing. Um, and so I've just been looking at various graphs that are similar. So I found ACOSH is pretty similar. I've never used it in school for anything. I don't even really know what ACOSH is. Might as well check out some other ones. A sign. A sign H. Okay, that one could be pretty wild. I gotta try that one later. Okay, so anyways, I've just been looking at some graphs. I just want to point out that ACOSH has like a cutoff here. And yeah, okay. Now, to the graph. So, the graph is pretty wild right now. Um, and let me just delete this for now. Right here. Alright, and so I'll just talk about a few things I've added. The first thing I'd like to point out is the fractal. The fractal, what it does is, if you're familiar with the modern art, actually, I don't know if he's modern art, but he's the artist who did the tomato cans. His name is Andy Warhol. His name's Andy Warhol, and he basically, what he did is he paints something and just splits into four ways, and he makes just the same image over and over again. And so that's kind of what a fractal is. It seems that in GLSL, that's what it does. It just takes something and splits it many times. You can offset what the split does, like offset the physical position and stuff, as I've seen using these variables. These values, and but another thing is that I want the behavior to be different when you go out. I don't just want all these circles popping and doing the exact same thing on your entire screen. So if I take away fractal, like I don't want something like this just showing up many times in many places. I want something else. So what I did is I made a variable called uv0, and basically it takes your position from the center of the canvas here, presumably, and as you get further and further away, the value of uv0 changes, meaning that your behavior also changes. And if you put this value of distance from the center into a function, you should just get something strange that should cause you to have some outcome that is different from the center, which is pretty obvious, as you can see from here. This central area does not look the same as one of like something in the corner. Okay, so I used the fractal thing, and then I decided that I'm gonna just have this. I'm just gonna multiply my functions by another function with uv0 in length. There's log, and then I talked about exponential, which is the opposite of log. Boom, super cool. What I discovered is that this does not seem to be a zoom in, but rather a density modifier. This value right here, because in the last video I was talking about how it seems to be a zoom in, zoom out, but I think it's just a density modifier. I don't really like exponential, I like log more though. Still sick nonetheless. Super cool. Let's see here. Oh, I added a time variable into the palette, which changes the the color, the pre-selected color at a certain location, which was a thing we had before but is not anymore. I like to make you maybe look at my cursor here, look at this dot, and notice how it changes colors when even when it's like at the same phase every time. Look, now it ended at a red color, this time it ended at a green color, and this time it ends at a cyan color. It's very different, and the colors are phasing in. It seems like even different formations are a different color too, which is super cool. Then I multiplied it by, I made a for loop. So for loops, I mean, everyone knows in computer science that a for loop is basically needed if you want to add complexity, or some type of loop is needed for complexity in a program. And well, I thought that's probably there must be a concept like that in making visual designs, so I put a for loop, and it's true. If you change the value of the for loop, or I mean the upper parameter, the upper limit of the for loop, you also change the complexity. This is 2. It is simpler than 3 for sure. This is 1, which basically means no for loop. Very simple as well. Pick 5. It's so crazy. Like, I would need a really big screen for that. It looks really cool though. 10 if you're curious. It seems like as the there's a lot of what I'd consider I think the term is serendipity. Like, yeah, this random chance discovery that just happens by just randomly increasing things. So yeah. Anyways, I'll bring it back to 3. Okay, let's see what's next. Oh, this was super cool. I deleted it at the start, but I just wanted to show you guys. If you put the eye inside here, I've been trying many locations to see what's cool. This is the coolest. If I put eye right here, it converges like a black hole singularity or something, and into solid colors. It is so cool. So I thought this was a zoom out function, so I was like changing it to try to get it to zoom out to see what is out there. But every time my screen looks exactly the same when the singularity occurs. So it must not be a zoom in then. What this value does, I concluded, is that it changes the density of the stuff on my screen. But since these are all solid colors, it doesn't matter. Yeah. So that was really interesting. I saw a cool visual, made a cool conclusion out of that. That was pretty sick. Oh yeah, there's a power function, which... Okay, so... how to explain this? Power function. The power function. Where's it? Okay, I just saw it, and I was looking away, so I didn't see it anymore. Oh, here's power function. This is the power function. I believe this is, yes, this is how the exponential it is. It's like the quadratic, I mean, well, this is the quadratic, this is the quadratic, this this is cubic, quartic, right? So it seems to accentuate the dark and accentuate dark and light to make things look more neon. Though that might have changed since I've messed with the code, but I believe, is it here? Well, it doesn't really seem to change much, never mind. Or is it right here? Yeah, so right here it accentuates the dark and the bright by changing the denominator. Okay, that was not relevant to what I was talking about, though. That result is not relevant to the application of using power to change the brightness. Rather, I just changed this value, which I've changed before. So yeah, never mind. Yeah, but I thought that was really cool. And since I'm here anyways, I might as well just fool around with some functions. So we have acosh, and a sin h. I'd like to try. Okay. So acosh, if I recall, has the black hole in the like that random bald spot, which should leave me with a black hole somewhere. Yeah, there's a black hole in the middle. Still really cool though. And if I do the density increase, the black hole still stays around the same size, which again proves my point of this being a density variable. Okay. And then a sin h, which does not have a bald spot in the middle, so that should be different. That's super sick. Wow, that's so cool. Though, it seems like because I'm not sure why, but this function doesn't seem to make the inside. Actually, it does. Never mind. I was gonna say it doesn't make the outside seem different from the inside, but it does. It's just that the amount of locations that look exactly the same is super large. It's like this whole area is basically constantly, almost always looking the same or looking very similar. It's not the same though, for sure. Okay, I think that's it. Yeah, that's pretty cool though. Yeah, that was just a little peek into what I've been doing for the last 2 hours.